So hello friends. Today this is actually the video on vectors part 5. I've been able to be I'm actually uploading the first 4 vectors part 4. I think everyone has been able to view it. I think everyone has actually been seeing that. So this is basically the vector series, basically in part 5. That is something which we're currently dealing on. So as I've already actually in the previous thing itself I told you that I'll be taking this vector part 5. Vector part 5 is basically on vector subtraction. In the first, we have already seen about vector basics, vector representation, vector resolution, which is how you resolute. That's a very nice video. Please try to see it. And the fourth one, we saw about vector addition. Three different ways to add. Vector subtraction is the last and the final part. Very useful one. But before going to vector subtraction, there is a part in vector addition itself. The basic thing in that is we can actually try to add magnitudes or find the magnitude. For example, if there is a vector like this, and there is also another vector like this. If this is can be a vector, this is b vector. What do you think is the angle between a and b vector? Do you think this is this angle? No. The angle between A and B vector is basically the angle which the A vector has to turn to align with the B vector. So this actually, if this is the way vector should turn to align with the B vector, and so this is the exact angle for this is the exact angle for angle between A and B vector. If we actually try to extend this line by VOA, vertically opposite angles, we can prove that this is the angle. So with this, let's try to line in another vector from here to here. For the B vector, the components we are just aligning it. So if we actually see like this, we can also draw another vector. Maybe this is R. Then we can be able to understand that if this is B vector, no. So this would be basically what? B sine theta. This would be B cos theta, and so this would be B. So this would be some line length. So with all of this, we can actually prove the magnitude R, which is basically equal to. I'll actually clear all of this. Okay. So if the magnitude of the A vector is A and the B vector is B, then the R is basically the root of A square plus B square plus 2AB. The angle between them is, if we just extend with a theta, cos theta. So this is one of the most important formulas. You definitely need to understand this formula. Without this, is one of the most important stage. It's like the developmental stage of a child. No, like that. It's one of the most developmental stage for vectors. Very important, very useful. Please know this formula. I am erasing it, but understand this formula. A square plus B square equals 2AB cos theta. Okay. Now. Um, now we will be able to study about vector subtraction. So vector subtraction is basically we start a vector, take a vector, go here, we take another slide, another vector, make it go here. So the resultant vector is basically a vector, b vector. If this is b vector, what do you think of b minus a vector or a minus b vector? Something which is very useful. So if this is the a minus b vector, I mean b minus no a minus b vector. So this is a vector minus b vector. This is the resultant. So this is how you subtract. But how this is done? This is basically yeah, you already see about the addition, right? A vector plus b vector. This is basically a plus minus b vector. This is the negative of a vector, which I already taught about in the vector basics. So basically, if there is a vector like this, a vector, b vector, this is the a plus b vector. But if we just take the minus, it's like this. And so this is a vector, b vector, and so this would be a minus b vector. So a vector, b vector, a vector plus b vector. This is minus b vector. So I'm sorry, this actually should be this way like this. So this should be a minus b, a minus b. I'm sorry. This a vector minus b vector. This is the value. So this is a very simple idea, right? This vector subtraction. Now let us consider the origin, a very important position vector. Now let's try to go to a new topic. This is what is known as a positional vector. Positional vector is basically a vector which is arising from the origin. This is the origin, right? So it is arising from the origin and going here. With position vector, we can actually know the components, right? With this component, this may be 3i cap something, 6j cap something. So with position vector, we can actually find a lot of things. With position vector, we can find displacement and so on. Something is very useful. So you can even try to do a lot of research in positional vectors. Positional vectors are just vectors which are arising from the origin and going through all the way to some coordinates. Maybe we can find the coordinates of that. um, Maybe this is a coordinate like this. They are asking the positional vectors of this. Maybe the coordinates is basically 2 comma 3. Then what is the components of this vector? Basically 2i cap plus 3j cap. Something very useful, right? So if there is another vector like this, we can find the components just as like this, and you can even find the displacement by using this vector subtraction. Vector subtraction, not displacement, the distance between the two vectors. Very useful, no? They may ask many sums like this, so please understand this also. So that's all, guys. This is one of the main things to understand. But there is also another thing I would like to say. Just like we have been able to find in vector addition, we are being able to find the resultant formula, which is actually given by r equals root of a square plus b square plus 2ab cos theta. There is the same formula like that in subtraction. For in subtraction, basically this could be a vector, this could be b vector. So this could be this could be a minus b vector. So this should be this will be a minus b vector, a vector minus b vector. This could be a vector, right? So the angle between the a vector and b vector is this angle. Okay, this angle is actually 180 minus theta if you are considering the theta for the angle between a and b for addition, vector addition. So if this is a vector minus b vector, the formula for vector subtraction is a resultant vector. For example, same thing. If this is b vector, a vector minus b vector, this is a vector. So unless of using this a vector, if this has a magnitude a, and if this has a magnitude b, the resultant vector is basically given by the formula r equals a square plus b square plus 2ab minus 2ab. This where we are making a mistake. Okay, many people make a mistake. Same thing, but minus 2ab cos theta. That's all, guys. So if this is r, a square plus b square plus 2ab cos theta. For subtraction, it's actually a square plus b square minus 2ab cos theta. This is actually a very useful formula, which is actually known as cosine formula. Cosine formula actually uses this because even in simple triangles, we can actually solve a lot of sums. Right. So that is something very useful and important. So hope you have enjoyed this whole series of vectors. I think there is a lot of people who are not actually subscribed to our channel. Please, in YouTube, if you go and subscribe, it will be very helpful for us. We are done with this vector part. So we have totally learned about vector subtraction, vector addition, vector basics, vector representation, and vector resolution. There is also something just called as dot product or k vector, which is actually not being taught in this, but soon I will be teaching that. Maybe if I get the time. Dot product formulas also there. Thank you, guys. So hope you enjoy this video. Please subscribe.